All right, in this video, we're primarily going to look at the code that's on the Arduino and make some modifications so it's a little bit more useful in terms of making the robot actually move around. For example, we want it to steer while also moving forward instead of just doing those operations separately. The state that we've got in our car too as well looks like this in a wiring diagram. We saw this at the beginning of the last video where we had connected the batteries of the car to the relay module and both the steering and driving motor. And what we did in the last video was add these 6 wires up here that connect to the control pins on this module and the microcontroller. So we use pins 5, 6, 7, 8. The exact way these are connecting, we figured out with prototyping. So these did jump around a little bit to get them correct. Moving these wires was one way to solve our issue of getting it to do what we wanted it to do. The other would have been to switch around the wires where the motors are connecting, the commons, or to modify the code in a whole bunch of different places. So our code, what we're going to change to make this more user-friendly is, one, we're going to stop using the loop area for our program because remember, this will happen over and over again. If we want a car to go through an obstacle course with a fixed set of routines, we want it to basically stop when it's done instead of continuing to repeat that. So I'm just going to comment this section out. It's kind of a useful chunk of code, so I'm not going to delete it. I may need to do some prototyping and testing if wires fall out later. From here on out, we're going to put our functions here at the bottom of the setup function, because remember, these operations starts at the top, works its way down, and it will only do it once. So that'll be perfect for doing one routine. Before we type in a routine here to kind of test this, let's go down to our user-defined functions and make the modifications that we're going to need to make so that we can steer and drive at the same time. Looking at go forward as an example here, you'll notice that our motor that is controlling going forward and backwards, motor 2, one of the relays is high, one is low, and that makes current flow through it. And motor 1, which is our steering motor, both of the relays are high. So no current flows through it because both sides of the motor are connected to ground of the battery. So basically every time I call go forward, it's going to do this to my steering motor as well. And that will prevent it from being able to steer and move forward at the same time. So I'm going to just comment out those 2 lines with the double forward slash. Now when I call go forward, it won't try to do anything to the steering motor. Whatever the steering motor was doing before I called go forward, it's still going to be doing that. I'm just going to be changing the state of the driving relays. So similar reasoning, we're going to do that for go backwards as well. We don't want that to change anything about the steering motor. Comment out those 2 lines. Little bit different here, but same thought process for the turning ones. I only want it to work on the turning relay pins, not the driving ones. So I'm going to comment out the drive motor commands. And same with this one. Full stop at the bottom. I'm going to keep all of these at full stop. I want to make sure that when I call this, it actually is putting every single, well, both motors into their closed state so they're not moving. Let's test out something here. In the setup function, let's pretend we're going to do like a L turn, right? So if I just want to have my car start, go straight forward, and then make a left turn. So that would be turning left and going forward at the same time. And then finally finish by just going forward a little bit more and then stopping. How would we think through what that looks like with our functions here? Well, first of all, the car starts from a full stop. So I need to make it move forward. I'll use go forward. And our go forward function, as we defined it, needs to have a number in the parentheses here, how long we want it to go forward for. So just so that we can see this, let's have it go forward for 1 second, 1000 milliseconds. Next, I want it to start turning left. So it's already going forward. So when I call go left, it's still moving forward, but now it's also turning left because go left no longer affects the drive motors. Let's have it continue with that going left for maybe half a second. So it'll be going forwards and turning left for half a second. And now to make it drive straight again, I need to kind of reset everything. I need to remove that turning left condition. So we could write another user-defined function that's just called go straight, but I'll work with what we have right now and use a full stop. I don't actually want it to stop for any amount of time, so I'm just going to say 0. But when I call this function, the thing that it does is, again, resets all the relays, right? But I don't want it to pause there. I want it to then immediately continue going forward, straight forward. And let's have it go forward for another 1 second. When it's done with this routine, it will continue to do whatever condition it ended up in. So if I ran this program right now, it would do this, and then it would continue to go forward for forever. So probably want it to come to a stop. I'll call another full stop. Cool. So let's see if this kind of does what it is expected to do here. I've changed the code, so I need to upload this again to the car before it's going to work. Plug in my USB. I'm gonna double check that the port is connected and it's the right board. They are. And re-upload this. So giving me an error message here, go left was not defined in this scope. So let me just look that, yeah, so they're called turn right and turn left, not go right, go left. So I need to make this turn left. Thank you, Arduino, for your debugging clue there. Let's try uploading again. All right, that's working out. Back over here, I've got the motor switch off, but let's turn this on. Let's see if I put the switch in the right direction. Okay, I think that's on. Double check here. And nothing is happening because by the time I turned the power on, it had already run through the routine. But there's a reset button on the Arduino right here. Every time you press this, it'll start your code over from the beginning, so it'll go through that setup function again. Hold this up and see if I actually turn the batteries on. Forwards and left. Okay, that went quick, but it went forwards and then it turned left and it was still moving forwards. Then you'll see the motors up here stopped and it went straight again, continued to move forward for 1 second, and then a full stop. Let's see that again. Forward, left, forward, stop. That happens pretty quick because we only said it should do those things for about 1 second. See it one more time. Forward and left, straight, stop. Cool. So that seems to be working out well. And we could obviously build out the code to do an even more complicated type of chorus and run around through a whole bunch of turns and twists. One of the issues right now is there's no feedback on the car, right? It's kind of stupid. So if it ends up getting slightly off course, it's not going to have any way to connect or correct for that. And that's where we're going to get more advanced later on, where we add in some things like ultrasonic sensors and bumpers, so it knows if it hits something, it can back up and try going in a new direction. One other thing that we're going to see before that, though, just to make this kind of base platform really usable, is going to be adding some speed control. You notice when the forward and backward motor kicked on there, that was a lot of power. It was going pretty quick, making a lot of noise. That might be too much. It might actually cause the car to spin out or burn out and throwing off its accuracy. It'd be nice if we had some way to turn it on at half speed so it moves with more control, or accelerates smoothly to its full speed so that it doesn't spin out and cause it to go in the wrong direction. We're going to use a transistor to do that, and we'll cover that in the next video.